Welcome to Vision Plus and welcome back to this Senior for Mathematics on complex numbers. We are now doing example 3 under argument of a complex number. Example 3 says that we are given 3 complex numbers and the question is that we need to find the principal argument of part A z1 which is given as 1 plus 8i. So we start by drawing the Venn diagram to illustrate the complex number, which is in that format. This is the real axis of the complex number z1. This is the imaginary axis of the complex number z1. This is the center origin. Now we have 1 and 8, both are positive. So in magnitude, 8 is bigger. 8 is on the imaginary axis. So let me mark here 8 and the corresponding negative 8 about there. 1 is smaller than 8, so it should be closer to the origin so that it is reasonable. So this is 1, this is the corresponding negative 1. Then you need to show the complex number. So the complex number is that we have on the real axis we have 1, imaginary axis 8, both are positive. So just look for the point where they're going to intersect, that point of intersection, approximately there. Then you draw the complex number, straight line from the origin up to that point of intersection. Then you put an arrow on top. Then you mark, this is my z1. But the question says that we need to find the principal argument. So the principal argument is the angle, is an argument actually, which is in this range. So from the positive x-axis up to where the complex number is going to be smaller than going clockwise from here up to where the complex number is. So this is our argument. This angle here is our argument. So what do? We need to extract this triangle. 1, 2, 3, and that point. So it is looking this format. I'm seeing vertically we have dotted lines, and then we have the hypotenuse in that manner. Then we join it to the opposite. So this is where our right angle forms for the triangle. We form somewhere here. Now, which angle are we looking for? We are looking for this angle here, which is here. You can call it anything you want. Let me call it A. Anything you want. A. Now, from here up to here is 1. From here up to here is 1. From down up to up here is 8. It's the same as from origin up to 8. So this is 8. So this is the angle. That means 8 is opposite to the angle. So this is where opposite is. Opposite. And then this one is adjacent to the angle. This is the hypotenuse on the longer side. Then you apply your saw, katoa. Sine, you need hypotenuse. Cosine, you need hypotenuse. Tan as opposite and adjacent. So let us just go straight with opposite and the adjacent. So what do we do here? Therefore, we shall say therefore tan of our angle we are calling A is given as opposite out of adjacent. And then we substitute. This gives us here now tan of A, opposite is 8, adjacent is 1. That means tan of A equals to 8. Then we get the inverse, so that our angle A now becomes the tan inverse or arctan 8. And you press the calculator. Tan inverse of 8, 82.87. I'm getting here 82.87 degrees. That is the arctan, tan inverse of 8. How do you press tan inverse on the calculator? You press shift and tan. So this is our angle. Now, if you look at this angle, Is it falling in this range? Yes, 82 is in this range. That means it is our principal argument. Why is it our principal argument? Because it is falling in the range of negative 180 and 180 degrees. Therefore, our argument arc of Z1 is 82.87 degrees. This is the principal argument because it is in that range. Otherwise, if it was not in that range, it could just become argument. We will just call it argument. And what is the value that can fall outside that range? The value that can fall outside that range is when we take it clockwise from here all the way up to there. That is clockwise, which means we would just say 360 minus 82.87. So argument alone of Z1 would be 277.13 degrees. But we are going to put the negative here. Why? To show that it was taken clockwise. This is what the question wants, but I repeat, we cannot penalize you for getting just an argument instead of the principal argument, because this angle here is the same as that angle there. Since it is the same complex number, it is just telling us the direction, and the two are pointing in the same direction. So this is the solution to part A. Let us go to part B.